Hello and welcome, everybody. Hope everyone is having a splendid afternoon on this hot and sunny Thursday. I want to thank you all for joining this webinar where I'm going to show you some amazing developments my team and I have been working on. Just a quick little introduction from my side. I'm Vian. I'm a consultant at MECAD Technologies, and I've been with MECAD for just over 6 years now. I've got around 8 years of CAD experience, and I focus mainly on SOLIDWORKS API development and automation. Now, before we jump in to the exciting new developments, I want to start with a quick story about someone I think we all know, even if you've never met him. Meet Jeffrey. Well, there's a bunch of people still joining. That's fine. The webinar is recorded. Just making sure. Meet Jeffrey, the engineer. Jeffrey studied engineering because he loves problem solving. He loves designing. He loves building solutions. He didn't get into engineering because he wanted to spend his day clicking the same buttons 100 times. Here's what happens in real life. Jeffrey starts a project feeling great. The design is moving, the parts are coming together, everything's clean and exciting. Then the project grows. Now Jeffrey's assemblies start getting heavier. Rebuild times get slower. Opening files takes longer, and suddenly the momentum disappears. And then the drawings start. Sheet metal parts, normal parts, assemblies, multiple configurations, revisions, views, notes. It's repetitive. It's time consuming. Always lands right at the end when deadlines are tight. Just when you think he's done, properties. Custom properties in parts, assemblies, and drawings need to be correct for BOMs documentation and downstream processes. But updating them manually across a big project is painful, to say the least, and is where small mistakes can become big problems. So Jeffrey spends less time engineering and more time doing admin. So let's help Jeffrey. We've done some research to back up all the problems in poor Jeffrey's life. For example, 30 to 50% of engineers spend their time preparing and managing drawings. Now that's just prepping and managing them. On average, we've seen it takes about 15 to 30 minutes per model in typical use cases. So this is obviously going to be different for everybody, depending on the complexity of the part. And 15 minutes is quite generous. I think people usually take a lot longer. Well, that's what we've seen anyways. But we'll say 15 minutes. And 60% of companies reported experiencing rework. This is a big one because it causes so much delays and it costs you money at the end of the day. This is due to miscommunication, inconsistencies, standards not being correct. It's not good. And in our 35 years of experience with multiple industries nationwide, we found all these problems lined up with what we as MECAD see. So today I'm going to show you 3 tools designed to give Jeffrey and teams like yours your time back. So let's dive in and I'll show you how you turn hours into minutes. Introducing the optimization package. It's a set of SOLIDWORKS automation tools designed to eliminate repetitive work and improve performance across real engineering projects. It focuses on 3 of the biggest time drains in most workflows: drawing creation, large assembly rebuild performance, and manual custom property management. The result? Faster turnaround times, more consistent output, and more time for engineers to focus on what they do best: engineering. First tool. Okay. Jeffrey finishes modeling and he thinks, nice, hard part is done. Then he realizes he needs drawings for every sheet metal part, every standard part, every sub-assembly and the full assembly. And it's not the drawing that's hard. It's the repetition. It's the same setup, the same views, the same steps over and over again. So the first tool I want to show you is drawing automation, designed to create drawings in bulk, consistently, and fast. We'll take a look inside of SolidWorks here. So you'll see on the right-hand side, this is where the optimization package lives. This is considered a normal add-in. So if I go to my add-ins menu, you'll see PDM, routing, simulation, and you'll see our optimization pack installed as well. So normal add-in. On the first tab, you'll see the licensing information. Licensing information, a great thing about this is it works on an online license method. You can be offline. You don't need to be connected to the internet. You have about 30 days, an entire month, to get back online with the internet to just refresh everything. So it's very nice. I love the idea. And you'll see your company, you'll see your expiration date, so you'll never have an issue where you run out unexpectedly. You see this every single time you use it, and you see your active products listed. Okay, here is the drawing automation tool. So you'll see these settings are still going to evolve a lot. This is still, the entire package is still in pre-release phase, even though we are releasing it in a special program. I think you guys will be very excited to hear about the program that we have in store. But yeah, these settings are going to evolve to give you even more control over how these drawings work to fit your workflow specifically. So I'm creating brand new drawings, don't need to override existing files. I don't need to generate, for example, if you make a mistake, you don't have to regenerate the entire drawing package. You can do it individually, only sheet metal, only normal parts, or just the assemblies. It's a lot of control. And you'll see each category there will have its own specific settings. For this one, I love to add this large ISO view in the assemblies. It looks pretty cool. Under my admin tab, this is where we come in, and we're going to specialize this tool specifically for you to match your company. You'll see we use your drawing template, we use your sheet format, and we use your bill of materials. We go so far as to defining the template as well. So we created this nice and interactive little template builder here. I can even take a screenshot of my templates. If you don't know the exact values, they're listed here at the bottom. You can still go just load a screenshot of your template and just hit save. As easy as that. Now you know the entire program knows where it can place the views, where the borders are, all of that fancy stuff. Big thing we built in, the skip rules. So skip logic was a big thing for our customers. For example, I can go into custom properties specifically of every single part. If the item type is equal to a buy-in, I know I don't need a drawing for that. It's the manufacturer has the drawing. I just need that for the purpose of procurement or for the bill of materials. I don't need drawings for it. So that's how you can navigate the skip logic, and we can do folder locations as well. So a lot of companies have a specific toolbox or common components folder. You just point it to that location, say, no, I don't want any drawings from there. It's fine. You can just concentrate on what we created. After that, you save the settings and we click play. Now, the moment I click play, it's going to scan the entire assembly for sheet metal, standard, and assemblies, and it's going to categorize them. For example, this one starts with the sheet metal parts, creates a flat pattern view, annotates the bends, creates the bend lines, all of that fancy stuff, as well as the standard views. Then it'll move over to the standard parts, the normal ones, in this case, a weldment. It creates whole call outs, it creates surface finishing, weldments, weld symbols. It really goes the full 9 yards. Then it will split everything into assemblies. So assemblies, you'll see some of them are being handled differently because this is according to the size of the assembly. You'll split the bill of materials, either bill of materials on one page and the views on the next, or if it's like this assembly, a small two-part assembly, it's going to keep the bill of materials on one page and the standard views with the balloons on the same page. You don't need 6 pages to describe a two-part assembly. So you keep it nice and tidy, keep it in one. And ladies and gentlemen, we finished. We took 1 minute and 24 seconds to create 11 drawings. To show you I'm not lying, I'll open one of the assemblies, or the main assembly rather, and you'll see we use a top level bomb. We can customize this for you if you want to use indented or something like that. We can customize it for you. In this case, it's just top level, and you'll see this nice little neat, tidy isometric view. On the sheet 2, this is the option that I set up for the isometric view that we want to create, or the specific sheet for the big isometric view. And you'll notice in the top right corner, there's missing balloons. Now, for people who worked with or works with a lot of assemblies, everybody knows the auto balloon command inside of SolidWorks. Works beautifully for smaller assemblies, the sub-assemblies or something like that. The only problem, and the big problem we found, is missing balloons. So even if you use the auto balloon command in SolidWorks, it won't tell you which balloons are missing because it only sees the view, it sees the components, and then it adds the balloons as it goes. If it can't see the component, if it's an internal component, it's not going to balloon it. And you won't know that until you go back to the bill of materials and constantly cross-reference the whole time to find out what is missing. So what we've done is we've basically redesigned this ballooning feature from scratch. So now it takes a look at all of the things. So it works exactly the same as the auto balloon feature, except it can actually now pick up if it's internal component. And if it's internal, it places this here at the missing balloons. So now I can see exactly what items are missing. I can go to my sheet 1, see, okay, number 4 is a spacer. Now, spacer will be an internal thing. So if I need it to be shown, I can just simply create a little exploded view, maybe a detail view, section view, something extra to show that component. It just makes life so much easier. And of course, it got your 4 standard views, small changes that need to be made, and you're up and running. Let's take a look at one of the parts specifically. I like to show this one because you'll see this is a sheet metal part. So you have your standard views, but you have an extra sheet with your flat pattern for your DXFs and your thicknesses. So you'll see this is a rather not unusual per se, but a little bit more complex in your normal box bends. It's an internal bend. So this is just to showcase, listen, this program can do very complicated bends as well. It's not just for your standard little boxes and then it goes and it adds that stuff. This has some real intelligence built into it to be able to figure out what is a bend, what is not, what's the closest edge, and give you all of the information that you need. Especially, the annotations as well. Go down 90 degrees with a 6 radius. It's really, really nice. It's fancy, as I call it. And then obviously in your views, you can just go and use normal SolidWorks functionality to move around, tidy it up a bit. For example, if I shift drag this 120 dimension, I have my dimension moved and still linked to the feature that it's referencing. I can take this radius, just drag and drop it onto this edge, tidy it up, and space everything nicely. And that's it. That's the amount of cleaning you have to do. So Just close these. So I need to save it. That is the power of drawing automation. Now we've done not just assemblies like this. This is a pretty small one, obviously, because we want to save a little bit of time. We only have so many hours in a day. We've done an assembly of 341 parts, unique parts. We've done in, I think, 41 minutes, something like that. It's crazy. And that was every single part. That's not anything that was skipped or the skip rules went in play there. So that is crazy amount. This works with huge assemblies as well. Taking a look at the performance of it, we've tested this tool a lot for the stability, for the functions, all of that stuff. 15,000 plus drawings automated. I think we're almost above, I think 18,000 or something currently that have been automated and have been tested and scanned through using this tool. And of those 15,000, we found it's about 10 seconds per file on average. Now, obviously, it's going to be faster or slower, depending on the size of the assembly, complexity of the parts, all of that fancy stuff. Compared to that lowball number, the 15 minutes manually, 90 times faster than a human can do it. Yes, there's a little bit of manual work that you just have to go and double check, move a few dimensions around, add a note or two. It's 90 times faster. It's incredible. I really couldn't believe the stats when I saw it the first time, but it's real. Numbers don't lie. So we're very proud of this tool. So next thing I want to show you is assembly optimization. Next, Jeffrey opens the assembly, and you know the feeling. It loads and loads and loads. Then he changes one small thing, hits rebuild, and suddenly he's staring at the progress bar thinking, this rebuild is going to steal my entire afternoon. That's where assembly optimization comes in. It's built to rebuild and optimize large assemblies to improve performance, rebuild time, and opening speed. So again, back in SolidWorks, the tools are all listed nice and tidy at the top here in the form of tabs. Under my assembly optimization, when I click Analyze Assembly, it's actually going to scan through my entire assembly tree, and it's going to organize the components according to a specific hierarchy. Now, this hierarchy is based on the rebuild order that it needs to be to make sure that everything from the ground up has been rebuilt up until your high-level assembly, your main general assembly. So that's why you see on the right-hand side, there is a level indicator. If this thing, by the way, just a small tip for you guys, if you're working with large assemblies and this guy, the level goes up until 20 plus, you are doing something wrong. Try and make your sub-assemblies a little bit bigger. Split your sub-assemblies, because the deeper it has to go, the more there is to update, if that makes sense. The more there is to relations it has to keep, to build, to think about. So try and keep this level as low as possible. So you'll see here 4 levels, quite a simple assembly, and it reordered these components according to their levels in the correct rebuild order. Taking a look at the options, if you have a massive assembly, you might just want to rebuild a specific range. That's why we built in from to, and we gave you a nice little number so you can see exactly what has to be rebuilt or what is going to be rebuilt. The drawings we just created, we want them updated maybe as well. If there's a geometry change, you'll anyways need to go into the drawing, update it, close it. We can rebuild the reference drawings as well. It automatically searches if it has a drawing. If it does, it rebuilds it. Then a big one is the image quality settings. The amount of engineers that we've seen that has incredibly high image quality for a bolt or a wheel or something it's embarrassing. It's not needed at all. You don't need to have this extreme detail to work on a simple, basic component. You just need its measurements. You just need to look fine. Doesn't need to be 4K, HD, using an RTX 3050 for the thing, for one part. So what we've done here is it will go through every single component and assembly drawing, and it will adjust the image quality setting to an acceptable level. It's not going to, make it look like absolute trash. It's not going to take it back to Windows XP. It's just going to make sure that it's a decent level of detail that you can work on comfortably, but also reducing the amount of detail going in that uses up your resources on your PC. And again, opening time, rebuild time extension. So it'll go that. A big thing also is by adjusting the image quality settings, it actually reduces the file size. You guys can go and test it yourself. Take one part, put it on full image quality, the most detail you can, save it and check it in the file location, how big that file is, and then do the opposite. Take it to the lowest, save it, and you can see how big of a difference there is between those file sizes. It's crazy. It's really cool. And then lastly, we have the optimized system settings. Your system settings is your entire SOLIDWORKS. So we adjust them and standardize them throughout the entire company, basically, to make sure that the settings are 100% optimized for the best possible performance that you can have. So that's a very, very cool and a nice option to have, especially the first time you run this thing. So I'm not going to rebuild my reference drawings now because there wasn't any graphical changes or something like that. I'm just going to use image quality settings. And when I say process, it's just going to warn me, listen, the documents are open. Are you sure you saved them? Because we need to close everything. I'm pretty sure. I'm going to click OK. And you'll see the speed at which it goes. So how we actually accomplish the speed is by doing everything in the background. You see nothing popped up while it was busy. It's because we're opening it in the background into your memory, in the PC memory, so it doesn't have to generate any graphics or anything. It works with the raw file itself and updates anything that's needed. Updates the references, updates the image quality, everything gets updated, which is very, very cool. And yeah, that's a rebuild process finished as quickly as that. Alrighty. So next thing, let's take a look at some statistics. So granted, this is the biggest and the best result we've ever had using this tool. And it was on an assembly that has 15,484 components, just to prove to you that these tools are made for massive assemblies, not just the small jack assembly that I have. It's designed specifically for the massive assemblies. So 15,000 plus components, of which 470 components are unique. So you can see obviously a lot of the components have been copied, and using your linear copy pattern, linear patterning and all of that stuff. Take a look at what big effect it has on such a large assembly. Now, you've seen almost a 50% decrease in open time alone. Now, we've done these in lightweight and resolved mode. The only thing you actually have to worry about is the lightweight one. So almost a 50% reduction in open time and 83% reduction in rebuild time. That's unheard of. That is really, really nice. So imagine saving 83% of your time. It's very cool. I just love showing this slide. That's assembly optimization. Finally, Jeffrey gets the dreaded message from the team. We need to update properties. Something changed. The project number, project code, a product code, or something has changed. Now it's not just one file, it's parts, assemblies, and the brand new drawings we created. There's descriptions, part numbers, revisions, project codes. Manually editing it, well, manually editing that is incredibly slow and risky. And if one value is wrong, we're all human beings, everybody makes mistakes. If one value is wrong, it affects drawings, bombs, and downstream workflows. So the last tool I want to show you is property definition. It lets you export properties to Excel for mass editing and then import them back in bulk. Again, a little tab at the top. We try and keep the interface as simple as possible to make it as user-friendly as possible. So 2 buttons, all you need. Going to start the export. We built in the option to actually extract the mathematical side of everything. So that would be the expressions. You can build math into this using Excel, all that stuff. It's really, really cool. I'm just going to use the evaluated values. So this will be like the mass and all that stuff. So that's perfect for now. I'm just going to go to my project folder, and the moment I click OK, it's going to go through every single file in that folder. It's going to open it up again in the background for the productivity of the whole exercise. And it's going to extract every single custom property. And this includes your configurations as well. So flat pattern configurations, the different sheets in drawings, should you need it. And it's going to throw it into a nice, tidy Excel document for us. Now, we are still working on the templates. We're going to make it pretty and all of that stuff. But this is just to show you the amazing, the actual use for it. So we can see that it's normal Excel. We can use basic Excel functions with it, all of the Excel functions with it. So macros you can use, anything that you need in your environment, you can actually build for you macros to make everything even easier if there's something that you standard constantly have to do with all your custom properties. Just to show you, I can turn on my filter here at the top, and for now, I don't need to update the drawings per se. So I'll just deselect my drawings, and you can see we want to approve Jeffrey Engineer. So maybe we can change this to, well, let's actually take my name. Hope I don't get into trouble for this. And that's it. So now if we want to go, I'll just clear the categories. And I want to only do the drawings for now, because I'm not actually going to update the drawings. And there we go. See, basic Excel functionality to make everything really, really easy. And you'll see there's a lot of properties that can be exported. Now, this is not just properties that we added. These are all of the custom properties inside of those files. So these will be yours. This wouldn't necessarily be, out of cutting length and things like that. It will be your specific custom properties that'll automatically be extracted. No extra work needed. Very cool thing we built in is we can actually change the units as well. So the document units, if you have to go to meters, kilograms, and square meters instead of the millimeters, you can change that here as well, and everything will update automatically. So we can just save this file, say, okay, cool, export was completed, and we can hit start import. We choose our little file over here that we just edited, click open. It's going to go ahead, open every single file location in there and adjust the custom properties. Make sure all the properties are there, and it also refreshes the graphics and rebuilds it to make sure everything's up to date. And again, this goes into detail. It goes into the configuration specifically as well, which is quite cool. A big thing about automation is you're unsure if every single thing has been taken care of. We're all human. We don't we don't all trust technology the way we should, and it's correct that we don't trust it. So we've built in reports on basically everything that we automate. So into the entire optimization package, we built in reports so you can go and you can make sure that every single thing, every action has been logged, every single thing has been done perfectly. If there was an issue, you can go back and you can check what the issue is. And that's what you'll see here. The report where it's been saved to, it will tell you, okay, cool, how many files. Just a quick overview of the report. And just to show again, go into the main assembly, and Mr. Me did it. We approved it. And that's property definition. So let's meet Jeffrey again. That's Jeffrey's story. He didn't become an engineer to spend his day rebuilding assemblies, manually creating drawings, or fighting with properties in hundreds of files. He became an engineer to design, solve problems, and build cool things. And that's exactly what the optimization package is for. So it's a nice little before and after. Before optimization package, after. Jeffrey is pretty happy. Hey, thanks for joining us, everyone. Before we jump into Q&A, questions and answers, here's a quick question for you. Would you like to see how this would work in your own environment? If so, there should be a poll popping up soon. If so, select the option on the poll, or you can just contact your MECAD sales team as well, and they'll take it from there. We'll organize a nice demo for you and show it how it's working in your environment. Yeah. Now, I'd love to open it up for questions. If you have anything you'd like to ask, whether it's about drawings, assemblies, property management, Jeffrey's mental health, or how this would work in your environment, please drop it in the chat and we'll go through them together. Now, while you're typing your questions, I'll answer our most common one we get. Does it work with SOLIDWORKS PDM? And the answer is yes, you can use it inside of PDM. Specifically, the assembly optimization tool is also great for it because it removes those typical, the file has been rebuilt warnings that pops up every time you want to check something in. It will decrease the file size as well, as I mentioned earlier, and the get latest commands, the get latest operation in PDM will actually take less time, including your archive. So if your archive server is massive, it's a few terabytes big, you can save space, a lot of space, doing just that simple assembly optimization procedure process. We're actually investigating some options to integrate directly into PDM. So for example, these aren't confirmed yet. It's just something that we're working on, maybe just brainstorming on. We want you to be able to create the drawings and automatically send them through a workflow as well. Then it might send an email to the entire team that the drawings are finished, and they can start one by one going through the drawings, making sure, tidying up, and then start submitting them for approval. And yeah, but again, this is just a small part of the exciting features we have in the pipeline for this thing. Like I said, this is still in pre-release phase. If you want to get your hands on this in the pre-release phase, please contact again. We'll come and demo for you, and we'll take you through that entire process that you need. Okay. Look at some of the questions. Yes, the recording is going to be shared. Just answer that. So the package actually, Flip Potgieter asked, how much does the package cost per SolidWorks license? So at this stage, we aren't doing it per license. You have a fixed amount you're going to pay per month, and then you can have it for your entire company. And that's unlimited amount of PCs currently. Now this is, so far, it's just going to be for the pre-release phase that we're doing this. So I'd suggest hopping on pretty quickly, but we're not really planning on changing that type of licensing method. We want the entire company to start using it, to start benefiting from this type of automation. So yeah, it's not going to be a SolidWorks license. For pricing and things, you'll have to contact the sales teams so that we can get you a quote out. We'll demo it for you on your stuff, and then you'll see the width, and then the price will make sense and all that stuff. Yaku asks, for Drawing Creator, what determines the placement of dimensions? Does your template files or sheet need to have locations for front, left, top, right views defined in template file? So the placement of the dimensions is all of the dimensions you used to create the drawing, to create the model, will be used to fully define it. Those drawing specific dimensions will be added to the drawing. Now, we have added the ability to manually stipulate which drawings you want. Oh, I keep saying drawings. Dimensions you want by going, while you're busy designing, you can choose, listen, okay, I want this one in the drawing. I want this one in the drawing. I don't want that one. But we found that it's much easier to put everything in and just afterwards just clean it up a little bit, delete what you don't want. Everything will be there anyways, so you can just delete what you don't need or move it around, like I showed earlier. The template files specifically for the views, the software automatically calculates the scaling and the positioning of the views depending on how you want it. For now, I believe it's third degree. Can't remember exactly, but it's the front, top, right, and isometric views that's being added automatically. We are working on adjusting that to different, that you can choose basically which one. But this entire drawing tool has been designed according to ISO standards. So we've taken a look, we studied the ISO standards, and everything is up to date, up to square with the standards of it. So you'll never have to worry about something being missing or something being wrong regarding to the standards. So the QA people will QA people will at least not be down your throat about anything. How does this work with PDM with checked in files? So currently, as we don't have it directly implemented in PDM, you'll just need to check out that assembly for the process, any process that you want to follow, because it does update. We do it on purpose that with each process it rebuilds and it updates, refreshes the document so that everything is up to date and on the latest. So we don't currently have a checkout feature, auto checkout feature just yet. That is in the pipeline, like I said. But yeah, you'll need to check out all the files quickly, run your operations, create the drawings, do what you need to do, and then just check it back in. And I believe that's a very simple operation inside of PDM, so not a big issue. Chandra asks, does it work with SOLIDWORKS 2024? This works from SOLIDWORKS 2024, 5, and 6. So the method that we're using is we're future-proofing everything, and this will be updated just like SolidWorks on a year-to-year basis throughout the months, especially with the pre-release package. We are updating on a monthly basis. Now we'll send you the stuff and say, listen, this is what's new. If you want to check what's new, then you can install it. If you don't have to. Just like SolidWorks, basically. So it does work with SolidWorks 2024. Yaku asks, can it add section views? Not currently. The only reason for that is without a human eye, where do you standardize a cut through a part? Every single part's going to be different most of the time. And where can we tell the software to cut it? Do you want to cut it on the front view, side view, front view? Where are we placing that? It's inside of there, we need to start standardizing it, and we found that we can't really standardize it at this stage. So only up until, for example, we are planning on adding something like AI. We're actually planning on adding AI and machine learning. It's a few years of work that's in front of us before we can implement that type of thing. But imagine like ChatGPT, you can give it a image and it will modify that image. Now we can actually give ChatGPT or Grok or Gemini or whatever, you can give it an image and basically move it around as it's almost a little bit more of a human eye onto that drawing. So then the dimensions and the stuff, it can double check, is all of the dimensions there? Are there any unnecessary dimensions? Things like that. So that will only refine it even more, even farther. So then maybe the section views will come into play and it might help. But again, it's difficult to standardize something like that. Johan's asking, what settings are you changing for optimization? Only image quality, or is there more settings, and does this change for different or more complex parts? So the settings that it changes is only image quality at this stage, because we found this has the biggest effect. The other settings that is being changed, because remember, it opens the file up, and then it changes it on a document level. So only that part is going to have its image quality lowered, and the rest of the settings we found is negligible. We can't really find any more settings that going to make this big of an impact on the bigger assembly size, on the opening time and the rebuild time. So yeah, that's basically the answer. It's only image quality at this stage. And it treats all of the parts exactly the same, because that's all what is needed for that big of a performance improvement. And remember, we don't want you, yes, it's a fire and forget, but we also want it to be done as quickly as possible with the biggest effect possible. And that's exactly what we've done. We've made it fast and we've made it reliable and with consistent output, and we're getting the best possible outcome currently, as you saw in that one slide. So Fiddly asking, does drawing automation let you choose the type of dimensioning you want? The type of dimensioning is actually very easy to change. This is absolutely based on your template. So where we choose your template, whatever settings are in that template is going to be used inside of all of your drawings. So it's just exactly like starting a new drawing and then dragging all of your views in, dimensioning, all those repetitive steps. We're just taking that template, doing everything for you in record speed, by the way. Can it generate an exploded view as well? Two parts to that question. One, we can't really generate an exploded view from scratch. So everybody knows it works with assemblies, your exploded view functions, you can pull it out and collapse it and expand it and all that stuff. Problem is, how do we know in which direction a part has to go? Circular parts, yeah, maybe we can get an axis and move it. Flat parts, which direction does it go? Because remember, the software doesn't really see the graphical interface. It's not human. But again, this is where AI can maybe step in at a later stage and throw that little bit more human eye on there to pull it out. We don't know which part has to come first, second, last. So that's the one part of the question. Second part is we are going to add a feature. It's currently actually in beta mode, that we're adding exploded views automatically to the drawings as well. So if there is a exploded configuration already that you created, it's going to throw it in into the drawing. If it's going to be an option to throw it in if you want it or not. And then it's going to throw it in, balloon that, and make it nice and pretty. And that's a beautiful thing. It scales everything automatically as well. It has the intelligence to do that for you. And 99.9% of the time, it gets it spot on, which is quite nice. Fiddly asking, can it generate building/house plans drawing with correct dimensions? We've never tried that, to be honest. Again, it doesn't work with 2D things. It works off of the 3D model. So I believe if you have the assembly or the not the assembly, multi-body parts or something of a, you can have a 2D sketch out your plans, and then just extrude that. Then all your dimensions going to be there. All of your everything you need is going to be there, because it's going to depend on what dimensions is in the 3D model specifically. It's going to use in the drawing. So that's a beautiful thing. You only do it on one side. You don't have to redo everything the whole time, which is where you save your plans, or not your plans, your time mostly. Hope that answers everything. If I missed something, please let me know. But if that is everything, I hope you guys have an amazing afternoon further. Hope you guys ate your lunch while you watch this, and I hope you are as excited as me. I'm really excited. I think you can tell. This is a game changer, I believe. And yeah, reach out to your BDE sales team, get a quote, and we'll see you guys in the next webinar.